So this is how proteins work. This is how all proteins work. It is universal. So the sequence determines the structure, which determines the function, essentially, right? So you can go from the code to the structure to the function. Those all follow very cleanly, right?
Yes, but we don't necessarily know what they're going to do based on their shape or even on their code, which is what Google's trying to figure out.
Oh yeah, that's real tough, man. That's real tough. No, it is really interesting, right? Because
they're getting really good at it, though.
Yeah, we can get really good at it. There's some things that we do know, right? In that, with some amino acids, which are the building blocks of proteins, with some amino acids, they have different properties. So I think sulfur, the amino acids with sulfur in can form these sort of, I think, they're called disulfide bridges, or basically these kind of like little bonds between the amino acids that have got sulfur in them, and that has sort of stronger links. I think that's one of the reasons that you've got curly hair, because in the sort of hair, the keratin there, you've got amino acids that have got the sulfur that have got the sort of sulfur in them, and they bond to each other more strongly. That's why you've got like tighter curls, you know? Yeah. And that's why you can sort of do chemical relaxation, because it chemically just relaxes those bonds.
That's how you chemically straighten hair.
Chemical relaxation, I think, works by sort of relaxing those sort of weakish but still somewhat strong sulfur bonds.
Chill out, sulfur bonds.
Pretty sure. This is all off the top of my head because I find this stuff interesting. But so the amino acids determine, the amino acids are the building blocks, right? They're determined by the genetic code, and the different properties of these different amino acids can result in different structures, and the structure of a protein is integral to its function, right? Like there's, an enzyme is sort of a catalyst. It's something that speeds up a reaction, and it's a protein that speeds up a reaction, and the shape of that determines what it can sort of interact with. There's different sort of ideas for how they specifically work, but the shape of an enzyme determines what it can sort of interact with. Like if it's speeding up one reaction, it's able to maybe bring the two molecules together in a way that makes them bond more effectively, right? And the shape of that enzyme is very important to be able to grab those two molecules and kind of put them together, right?
Like different pieces of Lego.
Exactly, yeah. So you can see how structure, sequence determines structure, determines function, and if the sequence is off in some way, like you can have a point mutation, you can have it be one part of the code, like one individual sort of digit be off, and that can cause a knock-on effect, right? Not necessarily incredibly likely to have like a massive effect, but it's definitely something that does happen, right? So changing that sequence results in issues down the line, and that's how we've got this sort of genetic cause for EDS. It's just there is a faulty gene somewhere that is not producing the right proteins in the right way. I say the right way, in a way, that causes them to work. This is really difficult. So you don't want to say as intended or anything like that, but in the sort of normal standard way that doesn't impede, your day-to-day life.